Okay, so this is the first reaction where we actually have to really consider which substituent will direct the other substituent to the proper place. And so when I first start looking at this, I'm going to start thinking about this and go, wait a second, if I add something while this is on, it would be an ortho pair director. But it might be the case that I have a meta director somewhere in the middle, right? Same thing here. We have an ortho pair director right now, but we knew that we had to get this from NO2, which is the meta director. But NO2 is not very good at allowing other things to come onto the ring. Therefore, I'm actually going to put this guy on first. And we need him to come on as a meta director, which means that you really need this guy first. Well, there's two reasons for that. There's a reason why I'm even thinking about him as a meta director, and that's simple. Remember, if you just add the entire alkyl group without the acylation, then what ends up happening is you get a carbocation rearrangement. So say that we were instead to add AlCl3 with Cl, boom, boom, boom. Well, if you recall, that actually would make a carbocation that looks like this, that would rearrange to form that, which means that your actual product would look like that, and that's not what you want. So since that's not what you want, we can't use him, can we? Okay, so instead what we have to use is AlCl3 in the presence of Cl, O, and do an acylation. Now this guy is now a meta director. So great, I can go ahead and put on my NO2 group, and I do that, and he would go to the meta position. We do that by adding H2SO4 and HNO3, and then wow, I can actually go straight from here to here all at once simply by adding palladium on carbon and H2, because that's a very strong reduction agent. And bam, we're done.